Okay, so if you turn to page 4 in your chapter 7 packet, we're going to go over another way of solving systems of linear equations besides graphing. Okay, and this method is called substitution. Now, substitution is something you've been doing for quite a while. So if I say to you, x equals 5, find 6x, you would all say, simple. I just let x equal 5, and the answer is 30. So what did you actually do? What you did was, where you saw an x, you substituted a 5. So instead of writing x, we wrote 5. That's the substitution property. So we're going to apply that property to this system of equations. So I'm saying solve if y equals 2x and 2x plus 5y equals negative 12, solve. Well, here, y equals 2x. So wherever I see a y, I'm going to write 2x. So down here, instead of me writing 5y, I'm going to write 2x plus 5 times 2x equals negative 12. What did I do? Wherever I saw a y, I wrote 2x. So instead of writing 5y, I wrote 5 times 2x. So to finish this problem, I say 2x plus 10x equals negative 12, or 12x equals negative 12. So therefore, x equals negative 1. Now, once I know what x is, I can then substitute negative 1 for x. So y equals 2 times negative 1, or y equals negative 2. So I always write my answer as an ordered pair, negative 1, negative 2. But I found the solution to this system by using substitution. So you can see on page 4, I give you rules for substitution. You always set one equation equal to one variable. You substitute the solution for the variable in the second equation, and you express your answer as an ordered pair. So let's look at another problem that we will do together. And the key for substitution is you always want to find a variable that has a coefficient of 1. You always want to use that, because if not, you're going to be substituting fractions, and that is not fun. So we look at these two equations and we say, okay, I want to solve this using substitution. So I have to find a variable that has a coefficient of 1 in either equation. So looking at these two equations, which variable has a coefficient of 1? And it's this one. So that means I'm going to rewrite this equation as y equals negative 4x plus 5. And my other equation is 2y equals negative 3x. So now, in my original equation, instead of using a y, I'm going to substitute negative 4x plus 5. So I'm going to write 2 times negative 4x plus 5 equals negative 3x. So you see what I did? I changed this equation into this. Then wherever I see a y, I substitute negative 4x plus 5. So this becomes negative 8x plus 10 equals negative 3x. I add 8x to both sides. I get 10 equals 5x, x equals 2. Once I know x is 2, I can then say y equals negative 4 times 2 plus 5, y equals negative 3, and I write my answer as an ordered pair, 2, negative 3. Then I go back and I mentally plug in both points into both equations and make sure that it works. So 2 times negative 3 is negative 6, and negative 3 times 2 is negative 6, so that works. 4 times 2 is 8, minus 3 is 5, so that works. Okay, so that's number 1. Now we're going to do number 2 together. And if you're a little confused, it's okay. I think after seeing number 2, it will start to click. So number 2 is x plus y equals 6. 3x plus y equals 15. Now, I'm looking for a variable with a coefficient of 1. And in this case, I have many, many to choose from. Okay, so it really doesn't matter what you do. I prefer to put things in slope-intercept form, so this seems more natural to me. So in this case, I'm isolating my y in my first equation, and I'm saying in the second equation, instead of writing a y, I'm going to write negative x plus 6 equals 15. So you see, I substituted negative x plus 6 for y in my second equation. Now 3x plus negative x is 2x plus 6 equals 15. I subtract 6 from both sides and I get x equals 9 halves. Okay, now I know y equals negative 9 halves plus, instead of writing 6, I'm going to write 12 halves. So I know y equals 3 halves. So my ordered pair is 9 halves, comma 3 halves. That's my answer. And I plug it back into both equations. Now 9 halves plus 3 halves is 12 halves, which is 6. 3 times 9 is 27 halves, plus 3 halves is 30 halves, and 30 halves is 15, so it works. Okay, so that is number 2. So now I want everyone to try number 3 and 4 on your own. If you feel like you can do it on your own, go ahead. If you feel like you need to watch me do number 3, watch me do number 3 and then stop the video and do 4. If you feel like you're good, stop your video now and watch it after you already have an answer. So number 3 is y equals 6x plus 5. So you notice here we already have y isolated. So instead of using a y in the first equation, I'm going to plug in 6x plus 5 for y. So I write 5x minus 4 times 6x plus 5 equals 1. I just substitute this for y in my first equation. So I get 5x minus 24x minus 20 equals 1. This becomes negative 19x equals 19, x equals negative 1. Then I just plug negative 1 in for x, and I get y equals negative 1. So my ordered pair is negative 1, negative 1. And again, always plug it back into your original system of equations and make sure it works. And this does. So if you haven't stopped the video yet, stop it and try number 4 on your own. And for number 4, we have x plus y equals 5, 7x minus 9y equals 3. So again, I could solve for either x or y. I, just because of slope-intercept form, always like to solve for x. No particular reason. So wherever I see a y in my second equation, I'm going to write negative x plus 5. So I do 7x minus 9, negative x plus 5 equals 3. 7x plus 9x minus 45 equals 3. 16x equals 48. X equals 3. And y equals negative 3 plus 5, so y equals 2. My ordered pair is 3, 2, which again, I'm going to plug in to both and make sure that it works, and it does. Okay, so now the final problem is a word problem. And it says one number, so let one number be x, is 4 less than 3 times another. So x equals 3y minus 4. The sum of the two numbers, my two numbers are x plus y, equals 36. So to solve this, I already have x isolated, and x is 3y minus 4. So instead of putting x in the second equation, I'm going to write 3y minus 4 plus y equals 36. So 4y equals 40. And y equals 10, and x equals 30 minus 4, so x equals 26. So my ordered pair is 26, 10. Okay, so that's the end of that video.